Good morning, student. How are you all? Okay, fine. Very good. And we have completed our topic Ampere circuital law for closed path that you have completed all. Okay, very good. And I think that's related the Ampere circuital law. You have also practiced some questions. Is it clear? Okay, very good. And now we come to the points. We have many questions in these chapters, and as you know that the first terms exam is coming for the 12th students. Okay, so you have to prepare for that. Okay, and as you know that in that exam, okay, at least marks you should obtain that you can promoted for the second terms, but no need to worry. I think that you will be the topper students in your class. Is it clear? Okay, now come to the point. We have another topics related your Ampere circuital law. Ampere circuital law, it means we have the second parts, means to prove Ampere circuital law you have to prove Ampere's circuital law for any arbitrary path. Okay, this is the second questions, and first we have done for the circulars. Arbitrary means what? The segments you will discuss here. Is it clear? Just like suppose that, okay, I have any types it is meters like that, okay, and one, this is the, okay, conductors which passes through these centers, and another is this ones, you can take like that. Okay, very good. Suppose that this is the x and y, through this the currents I flows. Okay, I current passes through these conductors, and suppose that O is the origins and this is the radius R1, this is the R2, this is the R3, okay, this is the R4, like that it may be many, that is the radii. Okay, and suppose this point is A, here is the B, here is the C and D. Okay, and the length of AB is DL1. You can take DL1, this is the DL2, this is the DL3, like that you can take. So here will magnetic fields, no? Okay, here will magnetic fields. Okay, here you can also find, here you can also take. Already we have discussed in the previous, okay, class. Now, if you will discuss about the angle, then here will be, this is the small angle, so you can write here d theta 1. What is the d theta 1? And here will be d theta 2. Here will be d theta 3, like that. Is it clear? Means here d theta 1, d theta 2, if you will add, then you will find out what will be the total angle. 2 pi 360 degree. Is that clear? Okay. So you will write here, suppose that let's I equal to current flowing through the conductor. Okay, current flowing through the conductors from X to Y. Very good. Okay, and R1, R2, R3 dot equal to radii. Okay, this is the radii. DL1, DL2, okay, DL2, what is this? This is the DL2, like that you can write. This is the a small length, can be right. So we can assume this one, and d theta 1, d theta 2, these are the a small angle. D theta means what? A small angle. Okay, this part are you able to see? Okay, now see, we can use the statements of Ampere circuital law, but before it, what you can write, since you have d theta 1 plus d theta 2 plus d theta 3 plus dot equal to 2 pi. Can we write? Okay. And another, you know also that since if there is the angles and this is the like as a arc, this means dl. So you can write since angle equal to arc by radius, you know this formula. Okay, so according to that, what you will write here, you will write d theta 1 equal to arc, that is the dl1 by radius r1. Okay, similarly d theta 2 is equal to dl2 by r2, d theta 3 is equal to what you will write here, dl3 by r3. Okay, so these are the value of the angles, or and more you can find out. Is it clear? So you write down the dot can be right. Now, according to statements of the Ampere circuital law, okay, according to statement, you know that the line integral of magnetic fields along a closed path is equal to mu naught times, means b dot dl. This is the closed integral, means closed integral b dot dl is equal to mu naught I. Okay, so that you will prove, but you know that this you can write. What you will write, b dot dl. If you will break these ones, then you can write in the addition. So here will be what you will write in which forms. You will write only b dot dl in the vector form you can write, plus, but the numbering 1 2 3 4 5 like that you can give also. Can we write? Okay, if why you will give the numbering, because suppose that this elementary here will be b1, for here will be b2, b3 like that. Then here you can also write numbers, here will also number. Okay, next what you will write, you tell me. b2 dl2 plus b3 dl3 like that, and here is the dot products, dot you can write. Okay, now you see that whenever you will remove, then here will be b dl1 cos theta, b1 number you can give b1 dl1 cos theta, plus b2 dl2 cos theta, plus b3 dl3 cos theta like that. But what is the angle between them? Since theta is equal to 0 degree, and you know that cos 0 is equal to 1. So you will write here b1 dl1 plus b2 dl2 plus b3 dl3, and this is the closed integral, that is the b dot dl. This you can write. Okay, students, the board is very small, so I think that you have some problems to see, but pay attention. Okay, say yes, this you can write, but what is the value of b? Since you have b is equal to mu naught by 4 pi into 2i by a means what? R. You will take this when the radius is r, no? Okay, so this value can you substitute here? Okay, but what is the value of mu naught by 4 pi? Mu naught by 4 pi is equal to 10 to the power minus 7 Tesla meter per ampere. Okay, so this value you substitute here. Then what you will write? Close integrals b dot dl equal to, you will write here at the place of b1, what you will write? Mu naught by 4 pi into 2i by r1 plus mu naught, and one more things we are leaving, that is the dl1. Okay, dl1. Another, what you will write? Okay, you will write here plus mu naught by 4 pi into 2i by r2 and dl2 plus mu naught by 4 pi into 2i by r3 dl3. Can we write? According to this, you can give the number here only. Okay, now what you will take common here? You will take common here mu naught by 4 pi into 2i, you take common. Then here is dl1 by r1 plus dl2 by r2 plus dl3 by r3, like that, dot you can find out. Okay, and another, you know that Same things you will write mu naught by 4 pi into 2I. But what is the value of dl1 by r1? You see that dl1 by r1. What will be the value? See here. Okay, dl1 by r1. dl1 by r1. Here is theta 1. Means d theta 1. So here will be d theta 2. Here will d theta 3 plus dot dot dot. Okay. And write same things mu naught by 4 pi into 2I and d theta 1 plus d theta 2 plus d theta 3. What will be the answers? Okay. You know that this will be the, you see here we have, okay, 2 pi. So you can write 2 pi. Can we write? Okay. Now some terms will cancel out. This pi to pi you can cancel out. And 2 to the 4. Okay, so this will cancel out. Finally you have mu naught. And this is the I. And left side you have what is close integral b dot dl. This is the, okay, formula. This is the formula that we got. B dot dl is equal to mu naught I. Students, with the help of the statement of Ampere circuital law, we got this formula, and this is the same things. Either you will take the closed path or any arbitrary path. Arbitrary path, you see that a small segments we have taken here. This is the small segments and each having some angles, but whenever you will add these totals, small angles, so you will get the 2 pi. 2 pi means pi value 180 and multiply, so here will be 360 degree. Is it clear? The total angles of a circles, what is 360, and here is many radius, so you can give the name r1, r2, r3, so that is called the radii, that is the plural word. Okay, I is the current flowings. All things I have mentioned here. I think that you should write these questions, okay, related your statements, and you can solve the numericals related Ampere circuital law. Okay, we will try to give some examples according to your questions, how we can find out, okay, the magnetic fields whenever the current flowing through the conductor. Simple things. Suppose that you have a conductor 5 ampere, 10 amperes. It means suppose that the I is equal to 5 ampere current flowing through these conductors. How much? 5 amperes. And you have to calculate what is the magnetic fields. Then you can find out the magnetic fields. You know that B is equal to, according to that one, so what you will take the elementary portions or the totals you can find out. You will find out, already you have. And what is the value of mu naught? Mu naught value you have. See, 4 pi you can multiply here. It means mu naught equal to what you will write? 4 pi into 10 to the power minus 7. And this value you will substitute here to find 4 pi 10 to the power minus 7 into 5 this, and you can calculate your value of B, that is the magnetic fields. Okay students, until now you have not subscribed my channels, please subscribe, like also, and share my this video. Okay students, thank you.